Hello friends, good afternoon. As you can see, we will study refraction formula for thin lens today. So I am gonna explain you the diagram first. As you can see here, this figure shows a lens bounded by two spherical surfaces AB and CD. These are the two spherical surfaces AB and CD, and whose radius of curvature are R1 and R2. As you can see, radius of curvature of surface AB is equal to R1 and radius of curvature of surface CD is equal to R2. And we considered it that this lens is placed in air. So the refractive index of material of lens is mu. It is also considered by us that the refractive index of this material of this lens is mu. So here, as you can see, the distance of the object O, it is the point object O, and the distance of this object from the pole is u. So after refraction, in the absence of this spherical surface CD, the image is formed at this point, which is I1. So the image is formed at I1, and the distance of the point I1 is V dash from the pole. So it can also be written here, the distance of the object O from the point from the pole O1 of the first phase is U, and the distance of image I1 is V dash. And we know that the formula of refraction through spherical surface is mu upon V minus 1 upon U is equal to mu minus 1 upon R, where mu is refractive index of the material of the lens and V is the distance of image from the pole and U is the distance of object from the pole and R is the radius of curvature. So in our case, mu is the refractive index is mu and the distance of image formed is V dash and the distance of object is U and the radius of curvature is R1. So it is the equation first, we have obtained it. So here we should remember this, the light ray passed through from air to the lens, so the refractive index is mu, and when after this case the ray will come out from the lens in the air, so the refractive index will be 1 by mu. I will explain it. But as you can see, in the absence of this spherical surface CD, the image is formed at I1. But during this whole process, as CD is present here, so this image I1 will be act as the object for this spherical surface CD. So this will act as an object. So after refraction, again after refraction means the refraction through the surface CD, the final image will formed at point I. So the final image is I, and the distance of point I or image I is small v through the pole. So as you can see this, that the I1 is the object in this case, so the distance of object is v dash and the distance of image is small v. So you can written here, now the image I1 act as an object for the spherical surface CD and thus final image formed at I. The distance of final image from the pole is v. And in this way, again the formula for refraction through spherical surface is mu upon V minus 1 upon U is equal to mu minus 1 upon R. And in this case, as I have explained you that when the ray passes from the air to the lens, so the refractive index is mu. But in this case, means after the refraction through the spherical surface AB, the ray passes from the lens to the air. So the refractive index will become 1 upon mu. If you didn't understand this, you have to watch my previous videos to clear the concept of refractive index. So here you can see mu will become 1 by mu and V is the V here. So the distance of the V is the distance of the image from the pole, which is V in our case, and the U is the distance of object, and the distance of object in this case is V dash, and mu is equal to 1 by mu, and R in radius of curvature is equal to R2 in our case. So now we multiply mu both sides. So here mu cancel and it is the equation we obtained. 1 by B is equal to mu upon V dash is equal to 1 by 1 minus mu upon R2. We give it equation second, and now we will add equation first and equation second. So this is our equation first and this is our equation second. So if you will notice that mu upon V dash will cancel after adding one equation first and equation second. So that we obtain 1 by v minus 1 upon u is equal to mu minus 1 upon r1. Here I have taken minus sign common from this equation, so we will get plus minus mu minus 1 upon r2. So here you can see that mu minus 1 is common in both the terms. So 1 by v minus 1 upon u is equal to mu minus 1, I have taken common, and 1 upon r1 minus 1 upon r2. This is equation third. Now if distance of object is infinite from the pole, then the image will formed at infinity. We know that if the distance of object from the pole, if the object is placed at the infinity, then absolutely the image will formed at focus, second focus. So we can written here, if the object is at infinity, the image formed at the second focus. So u is equal to infinity, then v is equal to f. So we will put the value of u and v in the equation third. So 1 upon f minus 1 upon infinity is equal to mu minus 1, 1 upon r1 minus 1 upon r2. So 1 upon infinity, we know that it is 0. So 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. It is the equation 4, which is the required refraction formula for thin lens or the lens maker formula. I hope you understood the whole concept, and if you have any doubt, you can ask in the comment section. Thanks for watching.